So what we are starting today is a journey that we are going to go through together, talking about thermal desalination systems. It's a course about water desalination, which is, in simple words, converting uh, either seawater or brackish water or any type of water which is not suitable for drinking, but basically converting into potable water or water that we can drink. So this is basically the whole thing about it. This is a very important issue and topic in the Middle East in general. Kingdom of Saudi Arabia in particular is the #1 of producing sweet water or desalinated water worldwide. The largest desalination plants, the largest quantity of water that we can drink is coming from Saudi Arabia worldwide. And there are some technologies for that. So what we are going to do through this course is basically going through these types of techniques, how we can desalinate the water, and how much it is related to energy, and how can the system be checked and evaluated for its energy consumption. Our target normally, like any other process, is to have the system which is producing sweet water to be efficient system. So efficiency of the system has got to be high, and the cost needs to be as low as possible. So these are the two elements that are going to bound, or they are going to set the limit when we do a comparison between different desalination systems. To do that, the course is going to be made of some lecture notes. There is no textbook per se for the course because we are covering a wide spectrum. Part of it, you will find it in what we call conventional desalination systems. That are the systems that you can see if you are driving into close to Al Aziziyah, where there is a desalination plant over there, or if you are going to Jubail, there is a couple of large desalination plants that are located in Jubail. There is another large, which is the largest in the world, which is located in Ras Al Khair, on the road or in the way to Kuwait. And there are several desalination plants that are distributed in several places in the eastern province here, and in the western province in Jeddah and Yanbu, and some others that are located whenever there are wells of brackish water that needs to be converted into sweet water. So it's a rich topic. It has so many applications locally here in the kingdom and around us in the whole Gulf region, the Middle East, and the whole world, as you will see from our presentation today. I'm going to share with you some course notes, and also I'm going to share a PDF version of a book, which is Fundamentals of Saltwater Desalination, that's been written or edited by Hisham al-Dusuqi and Hisham al-Tuni. It is the most classical textbook in desalination systems. For us, it is going to cover the conventional desalination systems. However, there are non-conventional systems that we are going to spend quite a bit of time, especially at the first part, maybe first month or 2 months of our course. We'll be talking about solar desalination systems that can operate, for example, with renewable source of energy, solar energy, how we can make use of the sun to produce sweet water from the salty water or the brackish water. So that's basically some sort of a nutshell telling about what is, it's all about, that the course that we have. In the course catalog, you'll find that I'm listing some of the desalination technologies that we are going to use. The prerequisites, as you can see here, it's heat transfer and thermodynamics. And the mechanisms that we have, we are talking about, for example, talking about multi-stage flash desalination systems. This is the largest systems of producing seawater desalination. For example, the plant in Ras Al Khair is producing more than 1 million cubic meters per day. The one which is located in Marafiq in Al Jubail is using a different technology, which is the multi-effect evaporation or multi-effect desalination, it is producing 800,000 cubic meters per day. And then there's the famous or the emerging RO or reverse osmosis technology, which is, we can say it's modulated. It's something which is flexible. You can put an RO system in the kitchen of your house, or you can have a large desalination plant made of RO systems. All what we have to do is bring that units together, and it's like a building block, like the Lego that we used to play with when we were kids. You can have multiple units of these. They are small in size. You can stack them so that you can produce more and more and more desalinated water. There exists units of RO that can produce up to 600,000 cubic meters per day, and they are going for more because what you do is just you stack units next to each other. My name is Muhammad Antar. The course notes are going to be shared with you in the Blackboard, and the same is going to be occurring for the textbooks. I'm going to share it with you also. There's no printed version of the book. It's out of print, but the author has granted me the access to distribute the book to whoever wants it, the students and engineers as well. The objectives of the course can be seen here. Talking about a comprehensive study of desalination, being able to differentiate between different desalination systems, understand them well, and know how to assess them, evaluate their performance, and how even to go into a design, which is talking about what would be the required surface area of the tubes needed for desalinating a certain quantity of water, and how much is the corresponding energy needed. So I'm talking about energy, which is actually, it's very much related to water. And that's why that the word or the sentence, energy water nexus, which is meaning that there is a very strong relationship between water and energy, because energy is what we need to desalinate water. Accordingly, talking about energy, then we are going to deal a lot with the first law of thermodynamics. Sometimes to evaluate the quality of the operation of our plants, we can use the second law. The thermodynamic power cycles, what we need from there is just to know that there is most of the desalination plants, the thermal desalination plants are connected to power plants. So a prior knowledge of what is Rankine cycle and what does it do is something which is needed. And this is basically what you have already studied in your Thermo 1 and Thermo 2. And then because we are talking about energy, then heat is going to be involved in. So the issue of talking about basics of heat transfer is another thing that will be needed. The outlines of the course here start with an introduction, which is what we're going through today and next class. And then we're going to talk about desalination using renewable energy sources, solar stills, the very old technology for desalinating water. Another technology that we have developed and commercialized, which is the humidification, dehumidification, desalination systems. We have the membrane distillation system as well, which is item number 8. These are representation of basically the emerging desalination technologies, and then the conventional ones that you can see a lot in the kingdom for producing a tremendous amount of water is basically the ones in the middle. Single effect, multi-effect, the inclusion of vapor compression systems, the multi-stage flash desalination systems. The course is thermal, however, because we are talking about water desalination, so we have to mention something about reverse osmosis, which is a fast developing technique worldwide for desalination of water. And we'll be talking about that. And then we'll be talking how to assess the price of water, how we can come up with what should be the price of 1 cubic meter of water as we are moving forward. There will be some sort of a design element in the course, which is something that we may discuss. That's something that can be done. You can do it as teams or you can do it as individuals. I'm going to prepare a list of projects that you can do. You can select between them, or if you are interested, you can come up with your own project. In normal situations, we used to do that kind of project as, or part of it as experimental work. now since we have limitation of experiments and going to the labs and so I think most of these projects are going to be some sort of analytical work. We're going to use the computer a lot in our calculations. You can use Excel. I'm going to see also how we can access and use the engineering equation solver, which is something I would assume that you have used that program in your Thermo 2 courses. And once I settle on the mechanisms that we can use the EES, I can at that time do some sort of a demonstration for those who don't know how to use it, and then you can get started in it. The evaluation method, this is basically what I have provided you as some sort of a first assignment or a pre-reading assignment so that you can go through it and see. We have things that are going to be done in groups, like projects, like discussions, and we have things that are going to be on individual basis, like homeworks that should be done individually, and definitely any assessment like a quiz or exam or so. The way I thought the course might be looking like is like this. Homeworks can be about 10% of the course grade. Your participation in class, in our meetings in Zoom, be it done on discussion groups or your share of probably talking about a subject or something that can take care of the class participation. The design or the project is going to carry about 15%. It's a group work. I was planning for a midterm exam. Then as the semester goes, let's see how we can do that. Because if you are going to come to the university in the middle of the semester, as we're hoping, then that's something that we can carry out in class. If not, then we can find a way that we run this midterm exam on the web. And then we're going to have a series of short quizzes, maybe every other week or every 2 weeks. We can make a small quiz, and that the summation of the quizzes is going to take care of 20% of the grade, and finally a final exam of 25%. I asked you to look at this and see whether this mechanism look fine for you, and tell me what you think. Any ideas for this balance?
Victor, do you hear me?
I can hear you. Just introduce yourself. Now what I can do is that I can put my camera off so that we can have a better communication. Just introduce your name and go ahead, please.
Yeah, my name is Hani Armayh. I'm a senior student. Yes. Doctor, when this exam will take place? Because there is no due date. So we can talk, I mean, if there is a conflict, I can talk to the other instructor, or here we can change it because there is no due date. This is the first question. And I hope the final exam and also the midterm reduced, and those grades goes to homeworks. So we can have like more flexible and more grades in our hand.
Okay. Okay, so I'll take your first question talking about the exam date. Actually, I did not put it because I would anticipate that most of you are going to have your exams on the 6th or 7th weeks. So maybe we can put it on the 8th week or so. So I was just, I thought I'll check with you first so that we can avoid any kind of conflict. So what you can do is that I'm going to put, maybe I can create a Google form, ask you to log in and put your exam times of all the other subjects, and then I can select a day which does not conflict with these. Does this sound to be okay for everyone?
Yeah.
Yeah, I find it a good idea.
Fine. About the grades, I can do something similar because we just need something that we can agree upon all of us. So I can put these elements in another Google form, share it with you, and then you can put what you think should be the percentage of each one of these elements. And then I'm going to share the results with you in our next class, and then we can discuss it.
Very good. Okay.
Sounds okay, then that would be fine. So that at least you just feel comfortable with the way that the assessment is going to go through the course. Going for more short kind of assessments with lower grades throughout the semester is something I also feel comfortable with. So if this is something that you like, for example, talking about the quizzes, I'm putting 20%. We can make it like 25%, and we can make something like 7 or 8 quizzes. So each one would have something like 3% or so. So this is something that we can handle. And then after this coming the course objectives, so I'll just write a note for myself that I need to make 2 Google forms. One of them is for exam dates. And by exam dates, normally we mean the midterm exam, because the final exam is already set, or it used to be set by the registrar. And then the percentage of each assessment type. Right? Now, our course objectives, what is expected is that by the end of this course, you would be knowing the various desalination systems to be able to apply the energy conservation equation, which is the first law of thermodynamics, into systems just to assess their performance. And that's something that we're going to do with the thermal desalination systems, as well as when we cover the RO system, we're going to do the same, because in an RO system, it needs energy. The energy is not thermal, but there is energy input to the process anyway. And then you'll be able to provide us with some sort of a professional presentation that can be done toward the last week of the semester. And that's something that we can, the groups of the projects, each group can do a presentation of the work. That's something that we have to mention about integrity, about the homeworks are going to be solved individually. Everyone solves his own problems himself. Exams are going to be strictly measuring your performance, so that something is an individual part. The group work is going to be a part in the project, and this is something that we can, you are allowed to work together and to give a project report at the end, but in that project report, you need to specify who did what. For example, member number 1 did this part of the work, member 2 that did that part of the work. So we should be able to, although the work is cooperative, there is a part of the grade on the group work, but there is a part on the individual contribution to each element of that. Any questions so far?
Please, thank you.
No, fine.